Linear inequalities in two variables. Tara na't ating pag-usapan dito sa ating matsayang talakayan. Kaya, stay tuned! Hello, grade 8 learners! For today's video, we will discuss linear inequalities in two variables. At the end of this video, you will be able to define linear inequality into variables and determine whether an ordered pair is a solution of a linear inequality into variables. Let us recall the properties of inequality. So in addition property, if A is less than B, then A plus C is less than B plus C. If A is greater than B, then A plus C is greater than B plus C. So in other words, we just added C on both sides of the inequality. For subtraction property, if A is less than B, then A minus C is less than B minus C. And if A is greater than B, then A minus C is greater than B minus C. As you observed, C is subtracted from both sides of the inequality. For multiplication property, if A is less than B and C is positive, so we have AC is less than BC. And if A is less than B and C is negative, then the inequality symbol will be reversed. So, we have AC is greater than BC. And for the division property, if A is less than B and C is positive, then A over C is less than B over C. And if A is less than B and C is negative, then we have A over C is greater than B over C. So the inequality symbol is reversed. Now, let us identify the property of inequality being described in each of the following. As you can see, 10 is added on both sides of the inequality. So we can now say that this is addition property. Next is we have n plus 21 is greater than 15. As you can see in the given statement, we have subtracted 21 on both sides of the inequality. So this is subtraction property. Another is we have negative 2a plus 5 is less than or equal to 25. In here, we have subtracted both sides of the inequality by 5 and then divided both sides of the inequality by negative 2. So, we used subtraction and division property. So, what is now linear inequality in two variables? It is an inequality that can be written in one of the following forms. AX plus BY is less than C. AX plus BY is greater than C. AX plus BY is greater than or equal to C. And AX plus BY is less than or equal to C, where A, B, C are real numbers and A and B are both not equal to 0. Linear inequality in two variables can also be written in the slope-intercept form. So these are y is less than mx plus b, y is greater than mx plus b, y is less than or equal to mx plus b, and y is greater than or equal to mx plus b. And take note, we have there m is the slope and b is the y-intercept. Let's have our example. Tell whether each of the following is a linear inequality in two variables or not. Number 1, 3x minus y is less than or equal to 12. The answer is yes, because there are two variables and use inequality symbol. Number 2, 19 is less than y. The answer is no, it is not a linear inequality in two variables because there is only one variable used. For number 3, negative 6x is equal to 4 plus 2y. The answer is no, it is not a linear inequality in two variables because it is a linear equation. Like linear equations, linear inequalities in two variables also have solution set. The solution set of linear inequalities in two variables is the set of ordered pairs that satisfy the linear inequality, meaning that an ordered pair xy, it is a solution of an inequality in two variables. It is a true statement that results when the variables on the inequality are replaced or substituted by the coordinates of the ordered pair. For better understanding, let us examine the given example. Determine if the points negative 3, 4, 5, 5, negative 5, 8, and 3, negative 5 are solutions of the inequality x plus 3y is greater than 3. So let us solve first negative 3, 4. The value of x is negative 3 and y is 4. So all we have to do is to substitute the given values on the inequality. So x is negative 3 plus 3 and y is 4. So times 4 is greater than 3. Then we have to simplify. So negative 3 plus 3 times 4 is 12 greater than 3. Then we have negative 3 plus 12, unlike sign, so subtract, so that is 9 greater than 3. So the statement is true. We can now say that negative 3, 4 is a solution of the inequality x plus 3y greater than 3. So let us have 5, 5. The value of x is 5 and the value of y is 5. So substituting these values or coordinates in the inequality. So we have there 5 plus 3 times 5 is greater than 3. Then simplify. So we have there 5 plus 3 times 5 is 15. So we have 5 plus 15 greater than 3. And 5 plus 15 is 20. So 20 is greater than 3. So the statement is true. So therefore, 5, 5 is a solution of the inequality x plus 3y is greater than 3. Next is negative 5, 8. X is negative 5 and y is 8. So, we are going to substitute these coordinates in the inequality. So, x will become negative 5 and y will become 8. Then, we have to simplify. So, multiply 3 and 8. So, the inequality will become negative 5 plus 24 is greater than 3. Then, combine this, unlike signs, so we have to subtract. So we have there 19 is greater than 3. The inequality is true. So we can say that negative 5/8 is a solution of the inequality x plus 3y is greater than 3. Then, next is 3, negative 5. The value of x is 3 and the value of y is negative 5. Substituting these coordinates in the inequality. So we have 3 plus 3 times negative 5 is greater than 3. So we have now to simplify. So we have to multiply 3 and negative 5. The result is negative 15. So we have 3 plus negative 15 is greater than 3. Then, combine 3 and negative 15. Since unlike signs, so we have to subtract. So, we have there, negative 12 is greater than 3, which is false. So, we can say that 3 negative 5 is not a solution of the inequality x plus 3y is greater than 3. And now it's your turn. Get your paper and pen. Then try this activity. For letter A, tell which of the following is a linear inequality in two variables. And for letter B, you have to determine whether the given points is a solution of the inequality y is greater than x plus 4. And that's for today, guys. Mag-practice at magtiyaga upang lalong maging magaling. Again, this is Teacher Dali na nagsasabing, practice makes perfect. Thanks for watching!